This is the motion of a rowing sweep stroke, which is further broken down at the top of your handout. We are analyzing the rower when they are midway through the drive of the stroke, because this is where the maximum forces are acting on the body. This is also the portion of the stroke where form is often compromised and slouching occurs. This image clearly depicts how posture affects the distribution of forces on the lumbar region.
In order to do calculations, first we had to make assumptions. We are assuming perfect weather conditions with no outside forces, that the boat is set, that all the forces acting on the lumbar vertebrae are in 2 dimensions, that the muscles are combined to act at one point, and that the anthropometrics are collected for a college-aged female.
We began our analysis by drawing a free body diagram on the lumbar vertebrae so that we could visually determine where the forces would be acting. From our free body diagram, we then used the equations of equilibrium to calculate the force of the muscle and determine that if the force of the muscle is significantly greater than the force of the oar, injury will not occur. Because of these assumptions that we made, we were able to determine that the force of the muscle was 1,883 newtons, and through research we determined that the force of the oar was 1,500 newtons. However, the force of the muscle was impacted by the angle of the rower's back. When the force of the muscle decreases, then more force is being applied to the weaker portion of your lumbar spine, resulting in injury.
Through our research, we came to the conclusion that the ideal angle of the rower's back is at 35 degrees. As this angle is decreased, the force of the muscles will increase, leading to a higher chance of injury. In order to minimize lower lumbar injury without compromising force, according to our calculations, it is essential that the rower has good posture throughout the entire stroke. This will minimize the compressive forces that are acting on the lumbar vertebrae and reduce likelihood of muscle fatigue.
Further research will need to be done to determine the exact angle that the spine needs to be at. However, this varies from rower to rower because no 2 bodies are the same. Further calculations also need to be conducted to determine exact forces acting on the lumbar region at different angles. This can be done using electrodes and comparing those results to known forces that the lumbar region can sustain.